Hello students, today we are going to talk about the three important relationship. One is Planck's equation, which was given by Max Planck, and other two are the equations given by Einstein, the mass energy relationship, and then equation for photoelectric emissions. So about this Planck's equation, I believe that you must have gone through this equation. Still, I want to recall because we shall be using it in the coming topics of this chapter. Well, E is equal to h nu. E represents the total energy carried by a radiation having frequency nu, and h is a constant known after his name, Planck's constant. Its value is 6.26 × 10⁻34 joule second. Well, the unit of this constant can also be derived from this relation. H is equal to E upon nu, and E is in joule and nu is per second. So that when reciprocated becomes joule second. Another equation is a mass energy relationship given by Albert Einstein. Well, in this equation he states that the total energy contained in a mass m of any matter is given by E is equal to mc square, where m is the mass of the body and c is the speed of light. Well, it means that when this mass is completely converted into energy form, we will get this much energy in joules. The third equation is Einstein's equation for photoelectric emission. What is photoelectric emission? Whenever light ray, we have already discussed that whenever light ray of particular frequency and above that is incident on a metallic surface, the energy brought by the radiation to the electrons lying in the outermost orbit of the atom may provide enough energy to the electrons so that these electrons becomes capable of getting themselves free from the attraction of positive ions of the atom, and if they still have some kinetic energy remaining with them after they have overcome this force of attraction or bond between the electron and the positive ion of the atom, then those electrons moves away from the metal surface, and this is called photoelectric emission. And for that Einstein gave this equation that the total incident energy is distributed in two ways. One is phi 0, which means the minimum energy required to make the electron free from the attraction of positive ions of the atom, which is known as work function, or also called threshold energy, and the remaining energy appears in the form of kinetic energy possessed by the electron, these photoelectrons which are emitted from the surface of the metal. Now here we are using K max. Ke max means the maximum kinetic energy possessed by the photoelectric emission, the electrons obtained after the photoelectric emission. The maximum kinetic energy of electrons due to photoelectric emission plus the threshold energy must be equal to the incident energy, means energy of the light ray incident on the metal surface producing or causing photoelectric emission. Here we are referring to maximum kinetic energy because of the fact that if light energy is incident on an electron, then essentially this threshold, the energy equal to threshold energy is being used and absorbed by the electron to break away from the parent atom, but the remaining unused part of energy may be distributed among the atom and the electron. So that means the remaining kinetic energy, the kinetic energy of electron may be less than the maximum kinetic energy when some fraction of energy is being absorbed by the surface other than the electrons. And so therefore not all the electrons will have this much energy, but the maximum kinetic energy available carried by the photoelectrons plus the threshold energy should be always equal to the incident energy, light incident on the metal, which is causing the phenomena of photoelectric emission. Certainly E is equal to h nu, E is equal to h nu, the total energy of the incident radiation is equal to h nu, where nu is the frequency of the incident light, and that must be greater than or equal to the threshold frequency, only then the photoelectric emission will take place. Nu is the threshold frequency, that is the frequency, the minimum frequency of light which can produce photoelectric emission in that given material. This threshold frequency varies from material to material, and phi 0, that is the threshold energy, is equal to h nu, which is h is the Planck's constant and nu 0 is the threshold frequency. K max, this is the maximum kinetic energy possessed by the photoelectric electrons. That's all for today. Thank you and have a nice day.